Let's move on to moment area methods. There are two moment area methods, and here is the first one. So we follow moment curvature equations and use dy over dx equal to theta, and it reduces to this equation. So if we move dx to the other side and then perform integrations, considering 2 points A and B, then the equation tells you that theta b minus theta a equal to integrations from a to b m over ei dx. This integrations, if you see it from m over ei plot, is nothing but the area underneath m over ei curve between a and b. So here is the integration. So it shows you that this area is equal to the rotation angle difference between B and A. So graphically, we can show it like this. So this is a deflected shape of the structures. This is point A and this is point B. Rotation angle for A is the tangential directions measuring from the horizontal positions. So this is rotation A. Similarly, this is rotation B. So angle difference, theta b minus theta a, is this angle. So this first moment area theorem tells you that the angle difference between B and A is equal to this area. So that's the first moment area theorem. The second moment area theorem, still following d theta over dx equal to m over ei. Again, move dx to the other side. So d theta and dx, if we draw the deflection shapes and then take out a small element dx, then d theta is the tangential angle difference between the two sides of dx. So if we take these equations and multiply both sides by x, so it will be x d theta equal to x m over ei dx. Now on the plot, x times d theta is equal to this distance called dt. So this dt is like a vertical distance projected by the two sides of this dx. So if we perform integrations between point A and point B using these equations, then it is doing this projection. So at the end, it stops at point B, and the projection is tangential lines of B. So this is exactly this projected distance we call TA/B. So as a result, it tells you that this TA/B should be equal to this integrations from A to B, x times m over ei dx. Mathematically, this integrations is equivalent to having the area underneath m over ei between A and B multiplied by the centroid distance measuring from point A. So instead of doing these integrations, what I can do is I can find the centroid of this area first and then calculate this distance measuring from A to the centroid and take that distance multiplied by the area of this yellow area. So notice that this second moment area theory is not reversible. So for instance, if I'm doing TA/B, which is the projected distance of the tangential line measuring from B, and the vertical distance from A, this TA slash B is not the same as the reversed, which is TB slash A. So this is TB slash A. So TB slash A is a tangential projections from A to the vertical distance of B. So they are not the same. So graphically, these two calculations are related through this graph. So this is M over EI plots, and this is point A and point B. This is a centroid of M over EI. So if you wish to find TA slash B, then you take the area times the distance between A and centroid. On the other hand, if you want to find TB slash A, then you take the area multiplied by the distance between B and the centroid. So again, they are not the same. So here's a summary for the two moment area theorems. So the first moment area theorems tell you the relative rotation angles between 2 points. The second moment area theorems tell you the projected distance between the 2 points.